All right, welcome everyone. This is an exciting talk on how do you use Async API to manage multiple protocols so that you can define a unified interface for your event-driven architecture. But you might wonder why uh, why you would even care about having multiple protocols. So let me give you some context, right? We've been working with several standards bodies, organizations like TM Forum and others who try to basically define standards for their members to enable interop between them. And as part of that, their job is to design and come up with API specifications. This could be Open API for REST or Async API for asynchronous communication like Kafka, Google PubSub, MQTT, and so forth, right? Uh, However, they want to define the interface, not the actual implementation. That is left to the actual members, how they would want to implement it. However, having a unified interface allows for better interop between different players, right? And that's the key thing here, which basically asynchronous, if you're in the asynchronous communication space, then Async API enables that. So let's quickly deep dive with that introduction. So like I said, Open API and Async API are kind of sister projects, but Async API kind of started focusing on like several protocols like Kafka, MQTT, Google PubSub, if you're doing JMS or things like that. And that's kind of where you want to be able to specify protocol specific stuff and protocol independent stuff in the same specification, allowing a clean specification. So you might ask, okay, that's fine, but what are the aspects that needs to be standardized when you're trying to design an Async API specification? So let's look at it. The first thing, of course, is your schema format, right? Async API allows you to, provide your schema definitions in JSON schema, also protobuf, Avro, and we've recently also added support for XSD. So there are many different formats in which you can specify your schema, your payloads. And so, for let's say, if you're a provider of, if you're a publisher of a particular message on a message bus or on a topic, then you would want to communicate to your consumers what is the schema format that they expect and what are the details of the payload itself. So that is captured through the schema formats, and you would want to communicate that in your specification. So that's great. All right, schema formats are important, and we know how to do that. What else, right? So the next thing that is important is there are several different integration or messaging patterns that are supported, and you would want to communicate that to your consumer in terms of how are you going to publish and what is the pattern that you're using. So for example, you could be using the request reply pattern, which is built into Async API, and in the request reply pattern, you would put a request on a topic and then expect the consumer to basically publish a message back on a reply topic, right? Or you could be doing PubSub, where you're basically broadcasting a message to multiple consumers or multiple subscribers. Event streaming is again another very popular thing. Or you could just be doing a simple subscribe, notify, kind of an pattern as well. So there are many different patterns, and for this specific API, what is the pattern that you're using needs to be communicated clearly, and that is actually captured in your Async API specification. Okay, what else? What else needs to be standardized? Something that's actually quite obvious, but sometimes not very obvious to people, is the topic name itself, right? On what topic am I expecting the message to arrive? And kind of being able to clearly communicate that is important, because there are certain naming standards organizations have and things like that to ensure a better interop, right? And of course, the next, which is very important, is the security aspect. What kind of security scheme is being used here? Is it OAuth? Is it a username, password, or a certificate based? And this is typically protocol specific, right? So what I mean by that is, if you look at Kafka, for example, Kafka allows you to authenticate at a topic level, but not necessarily at an individual message level. While something like Google PubSub has the ability to authenticate at an individual message level. So you could have access to a topic, but within that, based on your subscription, you could get access to specific messages only, right? And so there are implementation details in terms of the security aspects that are different, and those are protocol specific. So those also need to be communicated so that people know, your subscribers know what to expect, right? And many more. Of course, this is not a deep dive on the differences between the different protocols, but hopefully this should give you a idea of what are all the things that you would want to standardize. So now that we have, let's actually look at a sample application, because I want to make this a little bit more concrete for you to understand. And then we'll look at the actual async API specification and kind of go through step by step to understand how we are actually capturing all of these aspects. So let's say I have an order service which accepts orders, which also communicates updates to that order. And so you might have a client which might put a message on a new order topic, and that would basically be a request coming into your order service. And so order service would accept that new order, and then would want to provide a order ID back to the client so that they can track progress on the order itself. And that would be typically implemented as a request reply pattern in async API, right? So you would have a reply with the order ID and few other details going back to the client, through the VIP, work in progress orders, for example, topic. Okay, so that's great. You've got the request for a new order. You've given back the order ID. Now there could be certain backend systems. For example, warehouse might now get notified, and they might say, oh, okay, we do have all these items in the inventory. And so they may make a through another topic, or in some cases, let's assume they're making a HTTP request to the order service, and they may notify that yes, we are good to serve this order, right, to accept this order. And at that point, when the trigger is received, I'm making it, I'm calling it generically a trigger, because this could be a HTTP call, this could be an async call, this could also be for example, state in the database change or something like that, right? There are many integration patterns. So through any one mechanism, once the order service knows, then it would basically notify all the consumers. That could be the actual client itself in this case. It could be like a shipping application that wants to know that, yes, this order is ready to be shipped. So they would put a message on, let's say, accepted orders topic. Right. What else could happen, right? So you might have a shipping app that might want to basically notify the order service on on updates to the order. So for example, the order might be out for delivery, and the order service would get notified on this. So now here I've just tried to kind of communicate three simple patterns that are possible. And these topics could be either on Kafka, could be on Google PubSub, but it really should not matter, right? Like, to basically be able to communicate your design of this asynchronous system. And so what we would typically do is capture all of this interactions in an async API specification, so that anybody who's going to be building an order service, or anybody who's going to be interacting with the order service, understands what they are supposed to do, right? So this is a simple, again, example. Let's kind of jump in and look at a live demo where I'll take Kafka and Google PubSub as two examples, and kind of walk you through quickly what we can do with that. So let's look at the async API specification itself. Let me quickly pop open this view. So it's so there's different ways of looking at this. So what you will see here is we have defined two channels. One is a Kafka channel and then a Google PubSub channel. And then there are a whole set of operations like basically which are defining what is the topic, and whether this has a request reply kind of a pattern, and so forth, right? So if I were to come back here and just walk you through the this thing, so the async API YAML file itself. This is your description of Kafka, which is basically saying for Kafka, I'm going to use a simple username, password, security scheme. However, for Google PubSub, I'm going to use an OAuth scheme, right? And so you might have differences that you want to capture here, and so those are cool. And then you have a set of channels. These channels basically describe that I have a new order. That's the topic name, new orders. And then what is the message format? What is the message format that you're expecting on this? Similarly, you have a VIP, and then it has an order, a message format for it. And all of these different topics can be defined here with their message formats. And then there is a relationship between these channels that is described under the operation section. So if you go under the operation section, you'll see, okay, place order has an action receive, and that is going to be coming on this channel. This is the message format that is going to be accepting, and then it has a reply which basically says on this particular channel I'm going to be providing a reply, and this is the message format that will be used. Similarly, you could have an accept order or an initiate order delivery, various different things. And finally, here you have all the schemas. In this case, we are using JSON schema, but like I said, you could have Avro, you could have XSD, you could have different formats depending on what your application requires. So this is the simple JSON schema that all of you might be familiar with, which is basically describing this, and it has a sample example payload so that you can see what is the message that would be accepted by this particular topic. So that's a quick introduction to the actual async API specification itself, where we are capturing all of these things. Now, the obvious question is, what am I going to do with this async API specification? The first obvious thing is, yes, it's good to capture it, and from a communication point of view, this is clean for someone to understand. But if it was only for communication, it would be fairly limiting, right? So you could do a lot more interesting things. For example, you could do code gen from this, and this could generate the code for you, at least the stubs to start off with, the boilerplate code. But you could also use tools like Specmatic, which will allow you to use this as a contract test. Now, what I mean by contract test is that I can use this, async API specification, and I can verify if the actual whoever's implementing the order service is adhering to the specification or not. So let's quickly look at the test itself. So I have a little test here. All it's got is a before all, in which I'm basically defining where is the Kafka broker, and I'm going to also start the order service itself. It could also be started externally, but in this case, I'm just starting here. And then a simple tear down, which basically shuts down the application and stops the Kafka in-memory broken. So that's really all there is. The actual tests itself are going to be, so I'm just going to run this, and we'll see what happens. But the actual tests itself are going to be generated by Specmatic by looking at this async API specification and going through all the different topics, understanding the different patterns that are described in this, and then looking at the examples and basically putting the messages or expecting the messages on the respective topics, right? So all of that intelligence is picked into the tool and available out of the box. So all you really need is a async API specification and a simple one-time contract file. and that allows you to basically verify if an actual implementation is in line with the specification or not. So as you can see, already the tests have started running. So let's look at one specific test and see what has happened. So here we have a test which is basically a new order test, and it's saying on receiving a message on new orders topic, it should send a message on VIP order topic. So here what we will see is Specmatic test is publishing a message. So it's pretending as the client, and it's actually sending the message on the new orders topic. And this is the actual payload that it has sent. This payload is actually derived from what was specified in the Async API specification under the example section. If you didn't provide one, then Specmatic would automatically generate one for you. And then what has happened here is the message has been successfully published. Now you will see here the order service has received this order, and you would see that it's basically the same message that was sent. It is received because the format is if this was not as per the format, then basically that would complain, and you would not even have any issues at a later point in time. You would kind of catch these format or schema mismatch related issues right up front, right here. So given that it was the right format, it has actually captured this, and then what it's doing is now it's publishing, it's done some processing, and now it's publishing the VIP on the VIP orders topic. This is the ID of the order, and it's basically giving a few more information back. And then what you will see is the Specmatic test is actually waiting for a message to come, and finally it's received the message, and this is the message it's received, and hence it concluded that this particular test is successful. And this is a demonstration of a request reply kind of a pattern. Let's look at another one where basically it says accept order when triggered. Remember, we had said that there could be any way in which you could trigger the application. So when triggered, should send a message on the accepted order topic. And so here what you will see is there is a simple format in which we are triggering. In this case, we're just using a HTTP request. So someone's basically, the Specmatic test is basically called this curl request, and updated the order status. And as soon as the order status is updated, the controller received this. The controller then is going to publish a message on the accepted order topic, and then Specmatic test is going to wait if it's going to receive the accepted order as per this. So the application got triggered, the application did whatever processing, and then the order service had to put a message onto the accepted orders to notify others. And the Specmatic test is going to wait for this message, and it's going to receive this message, and it says, yes, I did receive the message as per the schema and schema format explained, and so this is all good to go, right? So these are a few different examples. Again, one last example where basically it is receiving a message on the out for delivery topic, and here you would see that Specmatic test is actually pretending like the shipping service, and it's essentially putting this message onto this topic. And then your delivery service has received this message, and then it's basically going to produce certain side effect, right? So maybe it's going to update the status of this particular order 123 to basically be status as shipped, right? And then what we're going to do is Specmatic test is basically now going to make a curl request for this order 123 with status shipped, and see if it's getting a 200 response back to make sure that that side effect was produced effectively or not, right? So this is just kind of quickly walking you through the different interactions that are happening and how we are able to use Specmatic to test whether those patterns, the schemas, the several things that we talked about are all being adhered by the application or not. Now, obviously, the question you might have in your mind is that I didn't see anything about the side effect or the trigger in the spec itself. So where is that coming from? Where have we specified these things, right? So if we go back to the spec actually doesn't have any of these things described. For those of you who are familiar with overlays, overlays is again an open API initiative. It's a great little kind of extension to basically enhance or customize your specification. So in a lot of cases, you don't want to overload your specification with lots of different orthogonal concerns. So it could be security, it could be testing related stuff. So in this case, what we have done is we have created an overlay file where we are basically saying for order accepted operation, basically add this Specmatic trigger, which is effectively this command to make a curl request, right? And then it has a timeout and things like that. Similarly, for initiate, you can specify a side effect and you can test if that side effect occurred or not. It's essentially a command, so you're allowed to put whatever you think is appropriate in your case. And this is how we can verify. We could trigger things so that the messages are put on the topic, or you could basically put a message and then verify if the respective side effect took place or not, right? Now, all of this I'm showing you so far with Kafka, right? Let's quickly jump and see the same thing. I just run before we started. The same thing you would see is running in Google PubSub. So let me quickly just show you the Google PubSub example. So here's the contract test for Google PubSub. And what you will see here is we're using a PubSub emulator. We are creating a PubSub emulator here, and then we are starting the application. And in the tear down, we are simply stopping the application and stopping the emulator, right? That's very similar to what we saw in the Kafka's case. And it's also referring to the same async API specification. So how is it referring to the same async API specification? If we quickly go down here, you would see that we have a configuration file, and in the configuration file, we are basically specifying a central Git repo in which you have all your contracts, which is your single source of truth. And from there, we are fetching this. So both Google PubSub, and if I were to quickly jump back to Kafka, you would see both of them are essentially referring to the very same contract, which is in the central contract repo, right? So both of these are referring to the same thing and working. And you'd see that the same 4 tests are also working here in case of the Google PubSub, topic, Google PubSub itself. So that's kind of, again, just a quick demonstration. While there are certain security-related differences between these two, the rest of the things are pretty standard and kind of captured all in this async API specification. So that's a quick demonstration. Now let me quickly jump back and summarize what we just saw. So this is part of a larger API design first approach, where you want your API consumers, your API providers, you want your architects, and you want your AppSec folks to get together and basically capture their agreement, right, in terms of how this API needs to be designed, what are the various different aspects that we just touched upon in terms of the schemas, in terms of the interaction pattern itself, and so forth. All of those things are agreed between these parties, and then they capture that in a standard specification format. So if you're in the REST land, then you would capture it in the open API. If you are in a asynchronous messaging based EDA architecture, then you would use asynchronous GraphQL, gRPC. If you're using SOAP, then WSTL. So there were different formats in which you can capture this, and this becomes now the single source of truth that both the providers and the consumer developers would refer to, and that would establish the interaction between them. This ensures that they don't kind of drift apart and start doing different things, right? So if I were to further step back, This whole approach is something what we've been calling as contract-driven development. And I'm going to quickly try and summarize. So you do an API design first, you come up with the specification. What do you do with the specification? You would put that specification in a central repository. It could be Git, it could be an API dev portal, it could be anything, but like some central place where essentially you want to make sure that that's the single source of truth. If you're using Git, then Git is a very developers, several stakeholders, developers, testers, architects, they're all very familiar with Git. They understand if I want to propose a change, then I go through a pull request process in which we do the linting to make sure it's as per the industry standard, the company standards itself. Then you would do a backward compatibility testing. Often, a lot of times, what happens is during regression cycle, you would try and test the application with an older version of a client to make sure it's still working fine. You may not have control to automatically upgrade everybody who's consuming your API. And sometimes you find surprises during regression testing, which is very late in the cycle. So what we're trying to do is shift that left and capture that at design time. And this is something which is kind of almost an accidental discovery that we made, where we have a new version of the spec that is coming in. We can take the spec and run it in a service virtualization mode, which means this will run as a stub or a mock. You can take the existing version, which is in the repo, and run that as test against this specification. So it's a no-code solution, and it's not a diffing, but it's an actual execution of all the tests that were working earlier with the new spec. And as long as all those tests work, then your new version of the API specification is backward compatible. There are other videos in which we have demonstrated this, so you can have a look, and then you would merge these changes, and those now changes are available in the Git repo. And so now a consumer could get started with their development. They don't need to wait for the provider to make the service available itself to them. And Specmatic will pull the latest version from the Git repo and start up and give you a service virtualization. Similarly, on the provider side, you can do almost a test-driven development kind of a style where you can run the contract tests. The test will fail because you don't have the implementation, and you can go through one by one and make all the tests pass, and that would make sure your implementation is contract compliant. Right. And then when you're ready, you could go into your continuous integration and again use Specmatic over there to provide you the stub or the contract test. And this will ensure that when you get to integration, you don't see any contract related surprises, which clears your path to production. So in a nutshell, what we're trying to do is we're trying to shift left all the way to design. We're trying to improve the DevX drastically by providing all of these things locally and in CI. And improve the collaboration between teams, because now everything is documented, is captured as specification. There's a great governance around this. You're also allowing teams to start in parallel, which drastically reduces the time to market. And finally, you're building your APIs to be a lot more resilient, and those are the building blocks of this. So that's kind of contract-driven development in a nutshell. And I hope this is kind of help you understand how you can leverage async API specification to define your interface, your EDA interface. Even though there may be protocol differences and so forth, how you can capture that. So thank you again for watching the video, and look forward to hearing from you.